What I'm going to do is a very general talk. For those of you who are already involved, this will be very simple. For those of you who are not involved, it will be still simple, but it will give you a taster of what we are about. I've called it QRP, why and how. Why should people want to do this strange thing? Why should we be linked with lower power than we need be? I've been staying at a B&B right by the lock, and this morning at the breakfast time there were a couple of ladies there who were quite young who had come over to see a friend, and they were staying the night, and they were very chatty, and they said, what was I here for? And I told them, and they said, what is it? And I said, well, we talk to each other on shortwaves. And she said, why? And it is a bit like that, because we are doing something we don't have to do. We are doing something that doesn't add up. We are doing something that is pointless every day. But that is the essence and the joy of life. Part of a hobby is we don't have to do it. It doesn't have to mean anything. It doesn't have to fit in with the world plan. And as long as, I think, as long as you can do one completely pointless and useless thing a day, then life still has some meaning. The QRPers, well, we use odd equipment. That was a transmitter that I built some years ago. I still have it. I found it and brought it. Runs about 1.5 watts out on 40 meters, has worked quite a few stations, and it was built on a piece of cardboard because you can build it on a piece of cardboard. And I simply poked holes through the top of the box and poked the component leads through and joined them as if they were a printed circuit board, but of course using the component leads on the underside. There can be nothing simpler than that, and you could go on the air and you could work quite a lot of stuff with that. It runs about 1.5 watts out. It's even got a decent low pass filter as well at the end. So we do use fairly odd stuff. We also use low power. The definition of QRP is generally using a power of 5 watts output or less. If it's single sideband, we normally take it as 10 watts. But the rule of thumb is 5 watts of power or less, which does seem an extraordinarily small amount of power to some. Some people would say that 100 watts is a low amount of power, but we use 5. And we still achieve good results. There are quite a lot of awards that you can win. This is a sort of starter award. This is the 1,000 miles per watt award. Is given to any combination that means you've worked 1,000 miles with 1 watt. So if you're using 5 watts, you've got to work 5,000 miles. Using half a watt, you've got to work 500 miles, and so on. It's 1,000 miles per watt at whatever kind of power you've used. It is fantastically easy to achieve. To be honest, I don't know why they even issue it. You know, it is a sort of starting point. It's something you could do almost any day, but at least you can have proof on the wall that you've used low power. So low power, simple equipment, why? Well, it works because of 1 or 2 simple facts. The first one is the nature of power on the HF bands. This is a rather contrived chart. I've used this a number of times, and some folk have said, well, you know, it isn't quite like that. Well, it is, in a way. What I've done is I've taken S points. You all know S points on your meters and your scales of your gear. And it normally means a 6 dB change. And I said, let's have a look at what happens when a transmitter reduces power. And I said, just for the sake of a starting point, let's say a transmission that has an output power of 1,000 watts is being received at exactly S9. By how much must the power be brought down in order to drop 1 S point at a time? And it follows this chart. S9 to 1,000 watts, your S8 at 250 watts. Your S7, 62.5 watts. Your S6 at 15.5 watts or thereabouts. Your S5 at 4 watts. S5 is defined as fairly good signals. Dropping from 1,000 watts to 4 watts, they can still read everything that you're sending. Why? Well, it's as simple as this. The chart assumes that one S point equals a 6 dB change, and 6 dB is a 4 times power change. The reason for that is our ears. They're not a linear organ. They follow a log scale, so the louder it gets, you have to, they say this, or the discos, you get to a certain point and it's so loud, and you've really got to pile on a lot more audio to make it sound louder. That's why young folk are perhaps on the edge of being deaf, because you really have to pile it on if you want to make it much louder. And that's why, if you look at all the scales we use, and there's a watt-meter scale and an S-meter scale, as they often are shown side by side, they are a logarithmic scale. Open at the bottom end, and you see there, the bottom end is open, the top end is more closed up. So you need to pile on the power in order to get a justifiable increase at the higher levels. And that's why the scales look like that. And that's also why, if you run 100 watts, if you're running 100 watts output and you want to gain 1 S point by increasing power, you've got to increase to 400 watts. Increasing power is an awfully inefficient way of trying to get a little bit more gain on the bands in order to get out a little better. Increasing power is not the good way to go. So we enjoy building little rigs, and it's a nice little one. This was built by SM7UCZ. It's an 80-meter transmitter built on a printed circuit board that is cut round to look like, and indeed work like, a Morse key, and operates from 2 AA cells which plug in the base of it. Runs about half a watt or so out, which is not a lot really, but you can still go on the band, you still work things. It's a novelty thing, but very pretty, and it shows what can be done. Another example of his work is a little transceiver on one board, and that's it, a complete amateur radio station on one board. He calls it the Alva, which is the Swedish Pixie, and in fact it's taken from a circuit that was in the States, was called the Pixie, and the transmitter and the receiver all on one board. It's on 80 meters, runs about 3/4 of a watt out. The receiver is very iffy. I mean, that's awful really, but it does work, you know. And if you want to run an exercise in saying what is the simplest thing I could build in order to go on the air, in order to work other stations, well, this would be it. The Swedish Alva would be the thing. That is a complete amateur station. Very few parts. I'll say more about that later. A good way to start with low power is to take a receiver that you've already got, or if you've got, and add a little transmitter board. One of the commonest transmitter boards that we've used over the years is from GM3OXX, and it's called the OXO. And obviously after his call sign. And you can see it's about as simple again a transmitter as you might get. If you look at T1 is an oscillator, a crystal oscillator operated as a VXO. VC1 at the bottom just pulls the crystal a little bit up and down, so you can move a bit across the band, but basically it's on a frequency that is fixed, but with a little bit, with a little swing. The output goes to a simple power amplifier, T2, and then the third transistor at the top, T3, is a keying one. It's a DC switch put there so you can key to ground. Now the OXO runs probably about 2 watts. It'll run on 160, 80, 40, up to 20. All you need to do is to alter the crystal, or you can, well, you have to alter both. Alter the crystal and the bandpass filter that you'll hang on the output. It's a lovely little circuit. George Bird, GM3OXX, is a person who runs entirely homebrew stations. Every bit of equipment he uses is made by him, and he never uses greater than 1 watt of power output. So all homebrew, all 1 watt and less. But George has over 320 DXCC confirmed. You might say, well, he must be using a big beam. No. He's only ever used antennas. He has a bit of space, but he only ever uses wire, bits of wire. And so, you know, it just shows that with low power, home built, plenty of stations that you can work. And the OXO for a while was produced as a kit. This shows the kit of parts for the OXO, and you can see what a simple thing it is. That is all that there is in it. Sadly not done in kit form now, but can I tell you, the QRP Club is about to start a range of kits, and we're going to do a little thing like the OXO amongst those kits. The other thing that George Burt was well known for was a little transmitter called the Wanner. So called because it fitted onto a 1-inch printed circuit board. And on the left is a version that I built, and I just simply put another 2 bits of board on either end to make a front panel and a back panel. The Wanner ran roughly a watt out. It depended on the band. On 80 meters, mine ran about 2 watts, but by the time we got up to 20, the highest band, it was down to about half a watt. You could use it on any of those bands, use it alongside a transmitter, a receiver of your own choice. And we did have a member who was seeing how many countries he could work on 20 meters using that alone. And I haven't heard from him for a long time, but he was up to 50 or 60 at one time, and that's all that he used. So, fun thing and a viable thing. Recently been replaced by George again by a little thing called the SP1, and this was designed to go alongside a receiver that he also did, and so he thought it would be nice if he could run it off a PP3, a 9-volt PP3, which probably wouldn't last for long, but at least, you know, as a novelty, you could have the PP3 inside its box. And this was the SP1, which looks more of a complex rig, but it's not. It looks a bit complex because there's the low-pass filter added on the back. This is a 40-meter version, and you see one at the bottom right-hand corner in the built form, and because of the voltage it runs only about 3/4 of a watt, so there's not a lot of power there, but that was the log that George sent using the SP1 across a range of bands over, I think, the period of a week. A pretty respectable logbook for a little self-contained rig that's running off a P3. And then we did the SP1 as a build-a-thon. A build-a-thon is where people come and they join in building the same thing. Normally we take a novice or two and we put them in a room, we give them a simple kit to build, and there are people who are used to being a constructor around who help them out. And the build-a-thon at Dayton 2 years ago was an SP1, and the build-a-thon version, which I showed you before, is on the right-hand side, and on the left-hand side is what we did the year after, which was a novel version of the Sudden, and I'll talk more about the Sudden later. a direct conversion receiver again for 40 meters. And Ken, W4DU, thought it'd be fun to see what he could work using those two very simple bits of kit in a contest. And so he went on, what was this, the 22nd of Feb last year, and I don't know what contest it was, but it was about 7033, 7032. And in 20 minutes, those are the 3 stations that he worked. Well, using a transmitter driven by a PP3 and a receiver driven by a PP3, that's not a bad country lineup. Work from Atlanta in Georgia, but you know, it shows that you can do things with it. They are fun, but they're not just fun. Let me tell you the story of a simple rig. Some years ago, Oleg, RV3GM, sent me a sheet of paper with a simple circuit to go in the G3RJV Club Journal Sprat, and that was exactly the piece of paper on the left that he sent. And it was a transceiver that he claimed was about the simplest that you could build. And indeed, when we looked at the Olva, that was based upon this. I don't know how well you read a circuit, but I'll just very quickly go through how this one works. If you look at it, there's a crystal oscillator. It's a version of a coal pit. The output is there, going to a power amplifier, which is T4 there, and a key there. His output is a simple tuned circuit on T4, and that goes to the outside world. So you press down the key, the oscillator oscillates, drives the PA, and you transmit out there. What happens when you lift the key? Well, plainly it won't transmit, because that isn't now in the circuit. But it's still in line with the outside world. And it's a transistor, a bipolar, and what are they really but a couple of diodes back to back. So, between the signals and a bit of tuning and the oscillator is just T4, the diodes back to back. And it becomes a mixer. And it's mixing the oscillator, which runs the whole time, with the signals that you're getting through the tuned circuit there, and you're getting an audio output. It's acting as a direct conversion receiver. And so if you put an audio amplifier on there, just a little simple audio amplifier with a pair of high impedance phones, you'll hear some signals. What a lovely device. Press down the key, it transmits. Lift up the key, it's a receiver. Very simple, very basic. Receivers, not very good, but it works. But that is about as simple a station as you could build. And when it appeared in our journal Sprat, quite a few people were inspired to take it a bit further. This was WA6BOY, who took the same basic circuit, better filtering on the input and output, and instead of the simple audio amplifier, he used an LM386. Very simple, but again, a station using a minimum of parts. And then that's someone else who went a little bit further, and that's got a couple of crystals, so you can get more of a frequency shift. Same kind of PA, a pi output filter, but this time a bit of audio filtering before the output. And it went on and on, and people took the simple micro 80, as it was called in the first place, and did additional things and added on and added on. I don't think it was a useful path. You know, you can't make a Rolls Royce by adding Rolls Royce spares on a Ford. You know, there is a limit, and at some point you have to say, well, that's a simple circuit and it must stay as that. But it was sold in large numbers as a kit, the Pixie 2, and that was the circuit version of the Pixie 2. my theme is always, in a general way, that amateur radio is a hobby. It's all about having fun. We shouldn't be under any pressures whatsoever. We should do entirely what we like. We should use it as a source of a contented life. The City and Guilds of London 3 years ago did a survey of, I think it was 40 different jobs to find out who were Britain's happiest workers. And they went around, I don't know, there's some sort of sheet they could fill, a scale of being happy with their work. Now then, who's going to tell me which job came top? Anybody like to offer? No? No offer at all. Well, you won't be surprised, or you might be surprised. It was hairdressers. But what a marvellous job. You know, somebody comes in, you sit down, you chat to them, you apply your manual skill, you finish off, they go away feeling better than when they came in. What a lovely job. You know, most folk are working on jobs, they never see the outcome of what they do. They're part of something that is huge and they are so small. At the end of the day, they can't point at anything and say, I did that today, or I made that, or I solved that. You know, most jobs are wavering about the whole time. Very difficult to go home at night with a sense of something done. And if you look at the list, V are the vocational jobs, and they're all Vs except for number 2, which is clergy. And the only reason clergy are second is they lied, really. well, ask a clergyman or lady, do you like your job? No, they're not going to say, oh, it's awful. Oh, no, I don't want to do this, it's terrible. Of course they're not. They're going to grit their teeth and say, yeah, it's good, isn't it? So, ignoring the clergy, all the rest are people doing manual skills. The components through, as you would with the printed circuit board, and then wire up underneath. This isn't the same board, in fact, but it's the only picture I can find. But you wire up underneath, and you use most of the time the excess leads of the parts. If you run out of leads, you just use some wire. And that is very much like a printed circuit board, only you're making the tracks yourself. And indeed, from the top, looks like a printed circuit board. Very easy to build again, nothing to etch, and you can work upon it as you go and change things with great ease. The other method of construction that's been in vogue of recent years is called Manhattan construction. This came from the States, and it's supposed to be that the parts stick up like skyscrapers. I think that's where it came from. And what you're doing with this is, it's similar, you're building onto a copper ground plane, you can see that in the picture on the top left. But what happens is, instead of suspending stuff in the air, you have a number of pads which are isolated from the ground plane. So you're joining your parts to the pads, and then that's joined to the same pad, and whatever, you build your circuit board up like that. And any components that are grounded go straight to ground, of course, in the same way as ugly. And that is a lovely way to build. If you want to integrate an integrated circuit, you can make a carrier, and that's one of the bit of printed circuit board. Cut it to size so that the pins on the IC drop into place. Score it with a hacksaw blade. Of course, one across there to part the pins on either side, and you can just stick it onto the copper-clad board and mount the chip onto the carrier. Lovely way to build things. Usually the pads and the All the carriers are stuck on with super glue, just a quick dab down and hold it down. Anything you can use to join underneath the board works, and this is another method using slug tape. You can buy this at your friendly garden centre. It's sold, it's a copper strip and it's sticky backed, and it's sold to go around the top of plant pots, and apparently it stops slugs going over the top. They don't like it, so they turn back again. But you can cut it into bits and you can put it underneath a board, and that can make your tracks. It takes heat quite well. It's not cheap. You have to cut little bits off it. And for the rest of the board, what you would do is use the top of the board as the copper-clad side, and wherever the leads are going through, this is one you have to drill, wherever the leads are going through, you drill a hole and then you ream it out. You can do that with a larger drill, and so the component lead won't touch the ground plane, but you can ground it straight to the ground plane wherever it needs to be grounded. And then the interconnections between these leads are done using the slug tape. So it's just like a printed circuit board.
Sorry, would the slug tape work for making up pads?
Huh?
Would the slug tape work for making up pads?
I doubt it, because I'm not sure what the insulation would be, because you'd only have a sort of adhesive between the tape and the ground plane. No, the easiest way to make the pads, they don't have to be fancy. You can buy them, you can buy nice round ones, but if you cut some strips of some copper board, nice long thin strips, get some tin snips and just snip them off on the square end, but that's fine. And very cheap, you're just using scrap board. But things don't have to look great, and this was Hans G3RJV. He built a low-speed Morse beacon for 30 metres, and that's it. And that thing that looks like a spider is his homemade heat sink. I think it looks rather nice. You know, it's sort of intriguing. It looks got a touch of the mad scientist about it. You know, it really is good, and it works a treat. And he just built it, and that was it. End of story. It's built, and it works. And I very rarely use a printed circuit board. There are some of the most recent things. These are all the practical wireless items, but I can't even remember what was on. Oh, a VFO, a regen receiver, a direct conversion receiver, which is a copy of a 1968 circuit, which was fun. I enjoyed that. And that's a version of the Sutton, which I'll talk about shortly. But none of those use any etch boards. All of them are based on ugly, and occasionally I'll throw in a few pads. You know, there's some pads there. So you can mix all these things, but you don't have to go to all the fuss of having an etched board. I think radio construction is a pilgrimage type thing. And by that I mean that the journey is just as important as arriving. The doing of it is what gives you the good feel. You know, you're working with your hands. The Greeks have two words for time. It's actually chronos, I think. Chronos is the one that we would know, clock time. But they have kairos, which is the other time, the special time, the unique time. And that's what radio construction is. It's that time where you say, oh, where's the time gone? It's that time that you say, well, time passes fast when you're having fun. It's that time when you're out with good friends and it flies by. It's that time when you sit down and you do some radio construction and you're at ease with yourself, at ease with the world, and you know it is fruitful. And I think that construction is like that. It's when I've built something, I will use it a time or two, And then I lose interest in it because there's something else I want to build. It sounds a bit of a perverse way to have a radio hobby where you spend most of the time building them but not actually making much use of them. But that's the way I am. But there is a sense in which any radio construction is about the journey. Where do you get things from? Well, of course, there is the QRP Club, which has been going, I think, since 1974. We have a journal called Sprat, which is a quarterly. The club is incredibly inexpensive to join. It's £6 a year. And we produce a number of things. We do have, in addition to our journal, we do have a number of books. There's the Antenna Handbook, which you can see there. We sold loads and loads of those. We also sell Sprat, our journal, on CD, and the current one is up to the end of last year. So it goes from the first issue right up to the end of last year. We also sell a number of other books. At the moment on our stand down there, advertising time, we've got a series of books by Drew Diamond, VK3XU. Brilliant books. He's a constructor who is absolutely superb, and he's allowed us to do his books. Everything in there is Drew. The designs are Drew. He made the prototypes. He drew the circuitry by hand. The photographs were all his. The text is his. So, you know, a true hobby book in a way. Everything in Drew's books are done by Drew. And we've got volumes 2, 3 and 4. Volume 1 is out of print at the present time. And then there are a couple of other UK books. There's the one I did, the Basics book, which is now out of print. We're looking at doing a new edition. And then, the collection, that's fairly recent. And Graham Firth, who's with me on the stand today, jointly with Tony, wrote a book on test equipment. I think there are still some of those as about, but it is running out of stock. If you want the best you can get, probably at the moment, if you understand a little bit about radio or want to learn more or want to go a stage further, that is probably the best book that you could get. Well, it is expensive, but it's not for what it contains. Authored largely by Wes Haywood, W7ZOI, and he was joint author with Doug Damore of the Solid State Design book. The Solid State Design has been out of print for quite a while. If you ever see one on eBay at a decent price or at a rally like this, buy it. Because I still think that's the book I use most of all. Absolutely full of goods. Anybody here has one? Oh, yeah. It's good, isn't it? Yeah. Very difficult to beat. So if you see that, sadly out of print, but if you see that, go for it. And any of the Doug Damore books. Doug Damore was the technical editor for the QST for many, many years. Retired a little bit young, sadly died since, but retired to his father's farm, a Michigan farm. Sold up a lot of the land, rebuilt the farmhouse, settled down to doing radio construction, writing, and doing books. And some of the books he did were really good and worthwhile. The design notebook or the QRP notebook are both worth reading. Very, very nice man. And an author you can understand. Very easy to read. Puts things in very simple terms. Some of them are in print, but any of them are worth doing. Those are, I have to include these, those are my 2 CDs of the left of the CDs that I did. I did a couple of books based upon a course I did at Dayton. The Minimalist Radio was the first one. And then I did a part 2 of that. And that was about simple construction and practical things to build. It was super because I had Paul Harden, who's call evades me. Can I read it on there? Yes, NA5N, who is a superb sketcher of things, did all the artwork for me. The books are out of print, but you can get them on CD. And then another occasion, I did a book of regens because I think they're lovely. A regenerative receiver is a delight to build, you know, and it takes you back to the 20s, and it works strangely well for so few parts. And so I did a whole series of them, and again there was a book on that, and that is now only in CD form. Available expensively on the club stand. Going back to the Sudden, at Rishworth last year, which is the club event of the year, we did a build-a-thon. Again, this is where people come and under supervision build things. Normally, folk who have either not built things in the past or have not really mastered it. And we had, I think it was 15 signed up for it, which is the most space that we had, including that young girl who built a Sudden. The Sudden was a receiver for 40 metres. And the circuitry you can see there, and underneath is the style that we built it. And that was built Manhattan style. And you can see the pads. There are pads there. The carrier for the 2 chips are there. And that was a 9-volt bar. And people paid for the parts, they sat down, had big instructions, easy instructions, and wise old constructors hovering around them. And everybody built one, and they all worked. And so, you know, a lot of people went home happier than when they came. The original Sudden goes back a long way. It's a receiver I did just over 20 years ago. And I did it when just after I'd moved to Rochdale, and I was actually vicar of the parish of Sudden. Sudden was, it didn't mean anything about speed or anything, it meant South Dean. It was the South Dean of the town. And I did a practical wireless request, really, for a simple one. And it was based upon an NE602, or the 612 will serve, and an LM386. Both quite useful chips, both of them a bit iffy in their own way, but very simple to use. The circuit was no great shake. The circuit is what happens if you throw an NE602 and an LM386 up in the air. That's the way they fall down. A Sudden is how they hit the ground. And we sold, or, well, the club was not involved, but it was Kanga kits in those days, did it as a kit. And they sold hundreds of them because they were used by schools and scout troops and so on for radio stuff. And so the Sudden got a good name for itself. Very simple. The NE602 is a poor mixer. The LM386 is a noisy, often unstable audio amp. But they're dirt cheap and they do their job. And it's amazing how well it works. And we used the Toco 10K coils as standard in the Sudden because there was a good range of them going through the shortwave bands. And having inductors that you can vary with a little slug in the top is a great asset. You know, it overcomes a multitude of sins if you can trim a slug. Sadly, the Toco coils are not made anymore. But fear not, there is good news, because Spectrum, Tony Naylor, in the south of England, is having a very similar range made, and that covers the shortwave range. And there it is, you see, it's a 10K can again. The base is exactly the same as before. The ranges are very much the same. Some of the matching is actually better. And those are the values we worked out for bandpass filters for all the bands. So now you can build a bandpass filter that you can slug tune using the standard off-the-shelf cores. Then they're not expensive, I think 75 pence each. So we thought we'd redo the Sutton because they'd come back. We altered it quite a bit. The present arrangement is there's no audio gain control. The audio output is actually balanced into the 386 there, and the only gain control is a little attenuator on the input. Simple and the best way, really, because you're doing all the reduction in gain at the front end, and so you're not bringing all the noise through and the cross mod through. Well, the G3RJV Club are doing a kit of this, and we were hoping to bring some along. It's an unusual kit because it's a Limerick construction kit, and this is a follow-through of the Manhattan, only in this method of construction. You have pads, so the surface mounted part, and you can't actually see them here, but the little links, oh, you can see one there, little links between the pad, that's under the mask, and you simply mount the components, kind of surface mount on top of the ground plane, and that shows an example of how it's built. And we were doing a Sutton, and we were hoping to bring them, but Easter and China intervened because we had them on a 3-day turnaround the boards by a company in China, and they failed to make. They were supposed to arrive before Easter, but they didn't make it before Easter, and we still haven't got them yet. But when we get them, they will be lovely boards, because that's what our board will look. It'll be black like that. That's a different project in the same method of construction. If you look at those scoring lines, you can just break them there. And ours will be like that. That's how the board will look, only it will be black like that. It'll have the break line there, the break line there, and you simply turn those panels round to face the inside, and there's a little solder slot on the underside of those, and that becomes the front panel, and that becomes the back panel. And your construction is on the pads on there. And I think it's a lovely way to build things. It looks good as well. And so we'll have a Limerick Sutton soon, but we hope that this was going to be the place where they were first seen, but you've missed them by a whisker. We still don't know where the boards are. We're chasing up the Chinese outfit right now. So nice, simple things to build as kits, and we'll be offering those as soon as they come. That was the QST in September 1924, the amateur builder section, a 5-watt sending set for $25. You can still do it. It's about the cost of making an OXO. It's it's probably less than that, the parts. That's that would be on the high side. You'd be going to a posh shop to buy your parts if it was 25, but it's less than that. So things haven't changed all that much between 1924 and now. I should say 2010 now. I'll close there because I've taken a full hour, so that's probably enough time. And what I'm saying is that amateur radio is a hobby. It's the first thing. We're not forced to do it. We can do it in any method or any style that we like. We can make it look as smart as we like or as scruffy as we like, because we've only got ourselves to please, really. And there are so few things left in life where people can do that. So few folk can sit down on a kitchen table or in their shed or wherever you do it and build something, and after spending time on it can say, I built that, it works. It does what I meant to. And if it doesn't, well, you're learning. You know, you're a pilgrim again because you're having to work out why it didn't work and sort it out. It's about the quality, not the quantity. That's what we find.